Good morning, everybody. My name is Noah Newman, technology editor with Strip-Till Farmer. And on behalf of Phycoterra, we want to welcome you to this webinar, Planting Ahead, Unlocking the Benefits of Earlier Planting with Smarter Residue Management. Very timely topic here. Our presenters are Dustin Blunier, Director of Agronomy at Phycoterra, and Chad Rubelkey. He's the owner of Rubelkey Farms, and they're going to help us unpack the agronomic and operational impact of that unmanaged residues. And so, Dustin, Chad, I'll send it off to you guys and you can get us started here.
Thank you, Noah. As he said, my name is Dustin Blunier. I am Director of Agronomy for Phycoterra. I am located in West Central Illinois. So we are in the middle of harvest season here. We're starting to see a lot of momentum. So those of you that are taking the time to join us, thank you. I know this topic around residue management is pretty popular this time of year. I was trying to think if it's probably not the most popular topic. Maybe it's more of, guys like to talk about harvest, yield, maybe the markets, but I don't want to bring up something too negative to start off on. So hopefully we've got a really positive a message here today around kind of residue management. And we're going to take a little bit of a different twist than probably what generally has been talked about when we talk about residue management. We're going to kind of talk about how we're seeing operational improvement and addressing some of the challenges that residue presents to, those reduced tillage, low tillage environments. So my key takeaway or my key hope for this morning and this piece is to just kind of see what the tools are and how you can look at different tools to improve, your soil conditions, planting conditions in the spring, and that's really at the core of what we mean when we're talking about planting ahead and being able to expand that growing season and earlier planting. So let's dig in to this. So I want to start off by talking about some of the values of residue management. And I think this is probably for most people in attendance, this is maybe some review, but I think it's important to kind of set the stage of what we're talking about. So when we talk about the value of residue management, we're talking about improving the conditions for that planter pass, improving planter efficiency by having a cleaner seed bed and having that residue, whether that's the corn stalk draw, into a position that you can move that planter and have that planter pass through in a very effective manner. We're also talking about optimizing your NPK or your nutrient availability. So we'll talk a little bit today, but obviously residue has your nitrogen, your nutrient components in it. You've spent all year building up that to build a crop, and as that decomposes, it's a huge source for building up plant available nutrients and soil organic matter. And so managing that timing of that release is a significant part of what we see within residue management. And then the other thing that we'll talk quite a bit about today is by managing residue and by accelerating that breakdown. One of the things that we'll share today is some of our research of how that actually impacts soil temperature. So when we talk about soil conditions and getting soil conditions right, one of the things that with a well-rounded residue management program, you'll actually be able to increase that soil temperature, get into that field faster, be able to accelerate or expand that growing season. And then also, as we look at it, a big component of this is as we've reduced tillage, as we've increased yields and biomass over the last few years, and with where our industry is headed, as we look at reduced tillage and different practices, are there different ways when you do that, you're increasing that challenge to manage and break down that component, that residue components. So what are those, where are some of those carbon and regenerative ag programs? How can that actually help build value into your program? So those are kind of some of the core things we'll touch on here. And just want to kind of help frame what we're kind of talking about as we work through this seminar here. So let's talk about the variables of residue management. So when we look at residue, there's value obviously in that. So what are the variables to extract that value? And really what we can do is we can break it down into kind of two things. You have too much residue at planting, or you have not enough crop residue. So when we're talking about too much residue, what you're going to wind up having is that's where you start having conditions where you get moist, cool soil conditions, because you blanket that soil and we impact the ability for it to warm up and get active in the spring. That's going to lead to poor seed bed conditions. So you're going to have more residue to kind of move out. We obviously want to get that residue component out of that seed bed so that it's working outside of it. You want good seed to soil contact. That heavy residue, it's going to cause you with planter efficiency issues, being able to kind of work through. And then the other aspects that we look at is if you have a heavy residue is a host for disease pathogens and different aspects of our disease pressure. So we're looking at that. And then a big one as well, as it breaks down, we'll get into the nitrogen tie-up it'll immobilize that nitrogen as it's breaking down, because it needs nitrogen and nutrients to feed that microbial community when it's working in there. On the flip side, if you burn that residue up too quickly, you're going to have exposed soil, and we want to keep that soil. We want to keep some type of coverage on that soil, and then having that healthy, the residue serves as a carbon source for that healthy ecology. So that's going to help with retaining moisture. It's going to help stabilize that soil environment. And so if we don't have that residue, if we're burning that residue up too fast, or in a scenario where we remove it as a form of management, we're going to lose nutrient opportunities, organic matter buildup, and those kind of things. So what we're really looking at, to kind of pull your favorite fairy tale or child fairy tale, Goldilocks, it was too hard, too soft of a bed, too warm, so too much, not enough. What we're looking at is we're trying to find that middle ground of where we're consuming and building our soil biology and returning those nutrients, but at the same time kind of maintaining these elements on these variables. So how does that look on a current paradigm? So I kind of pull this slide up. I think this should resonate. So when we look at how we're breaking down, residue management is really that breaking down or that decomposing, managing the decomposition rate. So we have to look at a couple of things, and basically I'm going to talk mostly on corn and wheat. This kind of can apply to really any crops, but those are kind of those big crop acres that we have large, heavy residue that we have to manage. And so what we look at when we look at those is corn has an average C to N ratio of about 40-1. Wheat's actually a little bit higher. It's about 80-1. And what we mean when we're talking about that C to N ratio is we're going to we're going to immobilize nutrients as we start to break down that residue. And then as we get it broke down, it's going to, and those organisms die, we're going to start releasing those nutrients through a process of mineralization. So I like this graph here as kind of a way to kind of guide us through kind of what we're seeing within that. And so as we look at that, what we're trying to do when we do tillage, we're introducing the residue into the soil ecology. So we're bringing the soil up around that residue, and that soil is full of microorganisms. And so when we bring that together with that and we bring moisture into that system, that is what breaks down that residue. So for years when we had heavy tillage and we would turn the ground over, obviously that would accelerate that process, and we would, I use the term burn up, but we would decompose that residue relatively fast, and that would return into that. As we've moved to more reduced tillage, what we're doing is we're slowing down that process. And there's advantages to that, but there's also some challenges that we have to work through. And this immobilization process is a significant part of it. In the current paradigm, we would look at, obviously, even with reduced tillage, what can we do to mix that soil or break down that soil? But then also we've used the practices of bringing nitrogen in. And that gets back into the C to N ratio and that immobilization. We're taking nitrogen away, so let's put nitrogen back in. It's the limited nutrient for the microbial growth. It's also what's taking away our yield, is because we've tied up that nutrient. We're not feeding that to the crop once we come into the spring. So one element to that is let's bring nitrogen into our system. The challenge with that is you're tying up, you're not really accelerating that biology. You're just basically you're basically compensating for that loss. It's an effective tool, but it's limited in its ability to basically generate that response of that release of nutrients that we're trying to get to, and that decomposition that we're able to manage that lower piece. And then the other aspect that we have that's becoming increasingly popular is added living biology in there. So we know, where we're familiar with certain bacteria and microorganisms that are particularly effective. So different companies have said, okay, let's bring that in, let's introduce that. The challenge there is we run into a scenario, where we're trying to do this is in a condition with lower temperatures as you get into winter. Those are going to go dormant as well. So those are kind of some of the current paradigm. I call it the paradigm, but that's the current paradigm that we're working in. Within that, all of them have limitations to what we can do. They're all good tools, but how do we effectively use them? And what I want to talk about a little bit today is an additional tool into your tool set, and that's microalgae. So Phycoterra is microalgae technology. What are microalgae? They're single-celled organisms that are naturally occurring in the soil environment. They are, to put it really, really brief, they're the smallest known organism to photosynthesize. So we have single-celled organisms that photosynthesize, grow naturally in the natural environment. In your soil environment, you have microalgae that are naturally occurring. They're the bottom of the food chain, and that's what makes them so unique and so valuable. Is your soil biology, the bacteria and fungi that are so important to that nutrient cycling and that decomposition of the residue, are going to be they're going to feed on, and they're going to be stimulated by microalgae. And so what we do with Phycoterra is we actually grow and raise microalgae and process that into a food source for your microbiome. And what's really unique about it is, it's a renewable resource because we're growing this. It grows very fast. And because it's single-celled, what is unique is we can grow it very consistently. So it's easy to replicate a single-celled organism in its growth process. So we've spent time, improving and developing that, just like a corn breeder or a wheat breeder would improve their genetics. We can do the same thing with microalgae, and that's what we've done with our crop of microalgae. Is we've developed a product that's very consistent in its space, and because of its single-celled structure, it's very adaptable and very easy to use within your cropping system. And kind of how we use it or how we focus it is, I want to talk a little bit about we use the term spheres. So you've probably heard of the term the rhizosphere or the spermosphere. Those are areas around in the case of the rhizosphere, the roots in the soil. The spermosphere might be a little less common, but around the endosperm or around that seed is what we have is defined as that area. And these are how the scientific community defines it is microbial hotspots or hot moments within the system where microbial activity has a direct impact on that plant or on that system. I like to use kind of the old 80-20 rule, where you have your soil environment, but really when you kind of think about it, it's kind of 80% of the work gets done right at that interaction. And that's where microbes thrive. That's where your microbiome thrives. So what we do with Phycoterra and that microalgae technology is, again, we process that down into a food source and we try and target our applications into these hotspots. So you can basically, not only are you long-term building up your soil microbiology, but you're getting that spike at the most opportune time to generate crop responses. So we do that within the seed and within that root, within the rhizosphere. We also have a new concept where we look at it foliar, and in a foliar environment, it's actually the phyllosphere. It's actually the interaction of microbes with the plant tissue. We're not going to talk about that today. The residue, the terminology there is the detritosphere, and that's what we're really focused on today, and where we're at with residue management is you need microbe community and you need that hotspot to break that down. And how that looks, I'm going to pull up here. These are what we call agar plates or little petri dishes. So to give you kind of a perspective of what you're looking at here, these are about a 3-inch diameter plate that we use in our soil lab, where we use to create cultures to help identify and look at bacterial growth. And what we have here is we have basically, we've taken the residue environment, and we've looked at that, we've cultured that onto the plates to see what we have growing and what we can stimulate. And so on the left, you have basically a standard residue. This is basically where we've taken corn tissue and we've put that on a plate to inoculate it for growth. And you can kind of see there that you have some bacterial growth that it's occurring. And then on the right, where we've introduced that food source, that Phycoterra food source, where we're trying to build that abundance and diversity of fungi and bacteria. And that's the key component of the soil that's going to promote that decomposition. Notice on the right, not only do you have more growth, but you can see in the picture, there's different shapes and different colors of the little dots underneath that. If you look on the left, on the right, you have the same kind of components. These are bacteria, and the hair on the right, it's on the left as well. The little hair-like substances is the fungal component. And fungi are really important to breaking down the lignin and the cellulose components of that plant tissue that we have in the residue, because what those little hairs are going to do is they're going to help break apart the structure of that residue component and create more surface area for the bacteria to go and feed and help basically mineralize those tissues. So what we're excited when we show that is you can see the balance and you're contributing both components to that. So this is an agar plate that's in the lab. What does that look like when we get into the field? And so what we have done is we've tested across a wide section, and what we're seeing when you can increase that diversity and you can increase that activity, we're decreasing our crop residue. We're measuring that decomposition rate. We're improving that decomposition from application in the fall to planting in the spring by 21% across all of our studies, across all crops. So that's compared to no treatment. That's no tillage. That's what you see there in the picture. And then the other thing that's very unique is we're seeing in that same time frame about a 3 to 5 degree increase in soil temperature at planting. Okay. And so those are significant value points when you're looking at how are my soil conditions improving and when are they ready to ready for that next crop come spring. Is, hey, I've got less mass out there that I have to move and manage through. And then also having that increased soil temperature, we're going to help with that dry down and having that higher temperature to where that plant's going to respond to germination. We're increasing that planting window for you in those environments. What that looks like here is, this is one of the studies. I pulled a study from Whitewater, Wisconsin, and this is the type of data that feeds into those numbers. So when we look at planting, the computer puts a nice graph in here, but I want to show you, basically draw your attention to these lines on this. The vertical lines are basically points in time where we've taken measurements of that temperature. And you can see here in this trial, we looked at our product at 1 quart and 2 quart rates. You can see why we recommend the 1 quart rate is we don't see a big jump by adding in that rate. It helps a little bit, but our economic point is at that 1 quart, and you can kind of see that this study reinforces that. But I want to kind of draw you to, you can see that microbial activity is creating energy, and what we're seeing is that energy creates that ability for that soil to increase in temperature. So you see kind of how that process works. We flip it over to that mass reduction, that biomass reduction, and this is the same trial that we had with those temperature. And you can see here where our treatment versus the check at those points, at the beginning of basically winter. And then as we come out of winter, you can see where that reduction is starting to accelerate. What does that look like? I'll just show you a couple of examples here. So one of our studies in Nebraska, you can see this is taken basically in April, right after planting in a no-till. This is actually a no-till environment. So you can see on the right, you've broken down, you've started having that microbial activity. It's breaking down. There's more surface area, and you can see that activity with that darker color, and that mass is starting to, it's much lighter if you'd be able to lift this up. Recognize those agar plates just to kind of show you that study. This is what's going on that microscopic level. Moving to another example here. This is in Rockford. I show this because one of the things with Phycoterra and with the feeding is we're feeding what's naturally there. We're not introducing new species. Our product is not living. The analogy that I would use is we are Phycoterra is to microalgae what flour is to wheat. We're the processed food. We're not the living organism. Like a wheat seed would be a living organism that's just dormant. We've actually processed it. So these are the native bacteria and fungi that we're stimulating within that residue management piece. And so I show it. It's a little bit different than in Nebraska soil. Everybody's soil would be slightly different, but you're going to get the same benefit within your process. And here's what that field looks like. This is again this is actually right before planting is when this grower took that picture. But you can see there again the breakdown, the fungi working to kind of help break that apart, create more surface area, and the bacteria starting to kind of feed and mineralize that within that. So that's the mode of action that we're introducing with our tool in this process. So with that, I'm going to kick it over to Chad and let him kind of share some of his experiences with residue management. So Chad,
Thank you, Dustin.
Go right ahead.
Thank you, first of all, through Phycoterra. We've had a 7-year relationship with this company. We've done multiple trials with them, and they've been great to work with. So again, thank you, Dustin, and glad to be here. Just a little bit about myself. I run a 3,000 acre small grain soybean specialty crop farm in central North Dakota. Along with that farm, we have a research and development company We do large scale field research. This takes place in our North Dakota site and also our Iowa site. So we have 2 locations as of today. And, we usually do between 50 and 100 full scale, large scale research projects a year through those 2 sites. Along with that, I have a consulting company, and we do a multitude of different things with that, I guess. But anyway, I'm here to talk about residual management. And through the 7 years of our relationship with Phycoterra, we've had we've had 30 sites of data that we've done large scale field research with. And we're going to talk about 18 of those sites. And these are the ones that we did residual management. And we covered small grains, corn, and soybeans. So just a little bit about these sites. All these were on full scale research trials. So we were using full scale fields, and we were using, our practices that normally we use, respectively as, commercial farmers. So we were in all climatic conditions through these 18 sites. We had drought, we were excessively wet, and some of them were on average conditions. Fall applied products, we targeted crops of everything from corn, soybeans, canola, spring wheat, durum. I think that covers them all, but they were 3-year studies through 3 sites per location. And these were, they were multi-year studies. So we were able to see exactly what the product did, but also on the longevity of the product. Okay, turn it there, Dustin. So through our 18 sites, I just picked a few of these to look at, just because we didn't want to overload everyone with data. But what was really interesting was the residual breakdown weights. So from our untreated to treated, we saw a significant difference and a significant reduction almost all the way through almost all of our sites. Now, as you can see, I did throw some sites in, like the 2022 durum, where our treated did weigh a little bit more than our untreated. And we are not perfect. So through our research, obviously there's differences on how that residual is spread out within the field, depending on wind and other such factors. So we are going to have some differences because of that. But when you bring all the data together, it's very clear that with the Phycoterra product, we saw a dramatic reduce residual breakdown, or residual weight, sorry. Dustin, you can turn it there. And how we collected these is we took a 1 foot square. We collected all the residual other than what was standing in that square. And we bagged these, and we photographed them, and we weighed them in our shop. I change it there, Dustin. So another factor that we were really interested in when we were taking these or doing these studies was spring soil temperatures. What was really unique is we started to see a correlation right away where our treated areas were significantly increase in temperature. I just took 3 sites just because I want to take a snapshot of the 2023 season. But in all 3 of our studies, and these were done in North Dakota, we saw abnormally high temperature reading with our treated zones. Now, for these readings, we took them at about 2 to 3 inch soil depth, and this was below the residual. So, right away, we can see it in 2023, but we also saw it throughout all the other years that we were able to, look at these studies. Turn Dustin there. And another metric that we were looking at was frost depth. So as we all know, when the frost comes out of the ground, it goes lower in the soil profile. So what we did was we took a probe and we probed the soil to see where that frost depth was at a certain time frame before planting. In North Dakota, obviously, we have a very short growing season. So this was very beneficial, I thought, to look at because, we're trying to usually plant on top of frost just to get that seed in the ground before our summer begins. So we took our frost depth, and what we found out right away was that our treated zones were a deeper frost depth than our untreated. So when we were looking at that, it was pretty apparent that the soil was warming up, but also there was more energy in that topsoil, creating atmosphere where that frost was coming out of the ground quicker than if it was in the untreated zones. What I wanted to do is I wanted to put the 2023 soybean, study up. And I thought that this was kind of an outlier, but what it showed is that with less residual, we do not see necessarily the same results as we saw with more of the residual, like on the canola and durum trial. So this was kind of flipped compared to the other trials. And I think this had a lot to do with we had very, very little residual going into the 2024 season. So when we looked at the study in general, we just didn't have the residual breakdown. We didn't have the biology going in this field to offset what we were seeing with our frost and with just the climatic conditions that we were facing. Hey, Dusty, you can change it. So this is just photos from our trials. Again, it's just our square that we were using for, pulling these samples and collecting these residue. But one thing that we really want to look at is when we were weighing these, this was kind of what we were seeing. So on all of our treated residue, we saw that darker gray color to our residual. But what was interesting about it and why I brought this photo into play was because the treated area was actually lighter than the untreated. And you can see that there's more mass to the treated area, but with the untreated, we still had more weight. So, I mean, that kind of shows you exactly what's happening with this product within that straw. I mean, it's not only breaking it down on the surface of the straw, but also inside of the straw itself. Okay, Dusty, you can change it. And I just wanted to bring this up. So we aren't only looking at the residual breakdown for a lot of these trials. We're also going full season approach with these products. And, we've done multiple studies with full season approach or just fungicide approach, you name it, throughout the season. We have done, different applications with the Phycoterra product. Just a little bit about it. So, we talked quite a bit about the fall applied, so the residual breakdown. But seed applied, we've utilized this product quite a bit with their seed treatment product. And it's mixed with almost all of our seed treatments that we have utilized. So we treat our seed ourselves on our own farm. And we've mixed it with almost everything you can think of. And it's been a very good product with mixability and dry fast on the seed. We've used it in furrow, so we've mixed it with a multitude of starter blends. We've always been very happy. We haven't ever plugged any filters. It's always stayed in the solution. I mean, we've just had a very good luck with the in-furrow application. Now, when you get to herbicide and fungicide applications, as everybody knows, when you're mixing in tank with herbicides or fungicides, a lot of products are sketchy at best. I mean, you got to really watch plug-in filters, efficacy, you name it. There's different situations with tank mixes. what we have found is with the Phycoterra product, we haven't had any issues at all. I mean, once you get it into solution, as long as you have it agitated, there's really no worries at all that we have found with the herbicides and fungicides that we have applied. And this is just kind of a little bit about how we look at the full season approach. You know, you have your residual breakdown. You can do early season with a seed treat or in furrow. You have stress relief, and I call it stress relief because in North Dakota, usually herbicide time, and it's either our plants are drowned in water or dying of heat stroke. So we like to look at it as stress relief at herbicide time and helps with nutrient uptakes. Stress relief again at fungicide, because normally in North Dakota, we're 40 below in the winter and 110 degrees in the summer. So a lot of times, during that fungicide application, we're looking for a little bit of help and a little bit of a boost there, because we just want to get those plants to reproduce accordingly. And then we have our harvest time frame. So if you want to go to our next slide, Dustin. These are just some photos that we had taken and kind of, through different trials that we have done on the North Dakota site. And first of all, we'll look at our seed treat in general. I picked out a photo of our soybeans and our wheat. What we find is we always have a lot better spring vigor with the application of the Phycoterra product. Along with this enhanced root structure. So normally we see these two when our conditions are tough. So if we have a cold, wet spring, dry spring, you name it, we'll see a lot better of a visual difference when we pull our root digs. So through these, I have probably, a million photos on my computer, and I'm sure that Dustin has a million photos from my site. So if you guys want to look at those, please contact him. But in general, every time that we are looking at a seed treatment, we're able to see it visually. Okay, Dustin. So when we get to the herbicide time in, we usually see that increased root depth of our plants. So, that kind of goes along and correlates with the seed treatment. I mean, we see just the enhancement continue throughout the season. And I know that, myself, like a lot of the other people on this call, have utilized products before that are utilized to help increase root growth, and that's all they're there for. This is different. What we usually see is a larger plant and increased growth from that plant. So usually our stem size is increased, especially on a soybean plant, but also our root growth is just a healthier, more vigorous root growth through the season. Now, foliar growth, normally we see a foliar appeal post herbicide application. Now, you could consider this because of the Phycoterra product helping with the atmosphere on that plant structure. Or, in my case, a lot of times we're using herbicides that are pretty caustic to everything that it touches, including the plants that we're trying to, or the crop we're spraying on. So, I mean, it helps that plant jump back and kind of rebound from that herbicide application. Next there, Dustin. Then we get on to the fungicide timing. And again, I'm sorry, I should have brought some photos from our corn trial or soybean trials from Iowa, but we were kind of focused more on the North Dakota region. So I thought I'd bring these up, and this would be a little more apparent. For the fungicide timing, a lot of times we see a little bit of a stress reduction with the product applied at fungicide. We have photos and we have a lot of data that represents an increase in pod set. So we're mostly, keying in on the canola crop at that point. But with the wheat crop in general, we see a reduced abortion within that head. So that's more kernel fill and just a more vigorous plant in general at that fungicide application time. And now for yield enhancements, this is usually where we see a great time frame for a chance of yield enhancement. A fungicide application, usually we're seeing yield enhancements, but not only that, but just a better, longer seed pod set time frame. Okay, Dustin. So I just wanted to kind of go over some of the takeaways from my personal use of the product. It's one of, I keep saying it, and I probably say it too much, but it really tank mixes with everything we have tried. I mean, just the other day, we put it with quite a few different potent formulas, and we're applying on a field here, I guess 2 days ago. So, I mean, it tank mixes very well. With our newer sprayers, we really have to watch for plug-in of filters and, a lot of different issues with the tank mixes in general. The Phycoterra product has been just dynamic when it comes to tank mixing. Like I said, it has no filter plug-in issues whatsoever. The only time that we really see an issue would be in furrow, and that's maybe settling overnight when you're going into really, really cold conditions below that 32-degree temperature. And that more has to do with just the water temp and the fallout. But anyway, going to the seed treatment, it's compatible with a lot of the seed treatments that we have tried. We actually do onboard seed treating. So our air seeder, we treat going into the tank itself, which is a lot of times pretty risky. You have to have some seed treatment that you know is going to dry fast, and you don't want bridging issues when you're utilizing it in an air seeder. We haven't had any issues whatsoever. Normally what we'll do is we'll just mix the Phycoterra product right into our seed treatment in general, mix it up and apply it right on board. There's a lot of visual difference, mostly again, in stressful conditions. That's when we see the most visual difference when we apply this as a seed treat. Herbicide treatment, we kind of covered that. It does add in foliar appeal. So I know that a lot of times, as a farmer, if something works, we like to see it, visually. And with this product, if you're out in the field, if you're pulling samples, you can usually see a visual difference. Again, with the fungicide treatment, canola has shown probably the biggest gain that we've seen on the farm, but also a lot of our trials with durum have shown very, very good results at the flowering application for a fungicide treatment. Okay, Dustin, if you want to go to the next slide. And I guess I'll kick it back over to you. Thank you, everyone.
Yeah, thanks, Chad. I'll just kind of bring it all together. So, we talked about those value points earlier and kind of introduced those, and, putting, some pencil to paper on what we've kind of seen from what is the value proposition on some of these things. So as you look at improving your planter, or we talk about planter efficiency here, but overall tillage savings, what we have kind of been able to calculate is, you can see kind of some of the numbers here of that's through, either decreasing the passes, saving money on equipment wear. We've ran some numbers, and we see really where we can reduce, and in heavily residue situations where we can reduce that biomass in that spraying, we're seeing significant, there's real dollars there. And so when you put all of those numbers together, you're talking, $60 to $108, even with some of the fertilizer prices I checked this summer. It's been a while ago, but you can see numbers approaching into that $100, low $100 range, and those are real numbers that you can really kind of start putting in this kind of environment. And so I want to kind of land the plane on that aspect of this with our webinar, and really just kind of reiterate, what we're seeing is when you can break that residue down faster, you're getting rid of that biomass and you're putting that back into the soil. B, that activity creates energy, and that energy is warming that soil. It's creating a more conducive condition for that planting window. And those are kind of the take homes that we're really excited about to bring forward and kind of to bring forward to the industry and to growers as a tool to kind of bring this in. So with that, again, thank you guys for your time. We'll open it up to any questions or anything that people would have.
All right, great presentation. Thanks for that, Chad and Dustin. And yeah, as Dustin said, time now to ask questions. Do you have any questions for Chad and Dustin? Let's see them. Q&A box, bottom of your screen, if you want to type those in. We'll relay those and get those answered. And also a friendly reminder, today's session was recorded, so you should get that in your inbox shortly after the conclusion of the presentation today if you want to share it with any coworkers, family, or friends. I guess I'll start with this question. Chad, I was interested seeing all your data from your trials. So I guess, was there anything that surprised you about the product, or anything that you saw from the trials that you're like, I wasn't expecting that?
Yes. I guess the biggest surprise we had was after utilizing the Phycoterra product for multitude of different years. Last year, we did a trial with their new dry product that's coming to market. And what was very interesting is that was a foliar product. And we were blown away by our yield results on canola foliarly. So, I mean, just absolute amazing results that we've seen with the product, utilizing it in a multitude of aspects. And that's something that you usually just don't see with a product that you can, the versatility is very cool to see.
Yeah, you mentioned the versatility. Dustin, from other trials you've seen, is there all crops respond pretty well to Phycoterra, or is it are there only certain crops for it?
Great question. I use the term we're relatively crop agnostic. We're feeding the microbes. If I had to give one sentence, we're feeding that microbiome, and so that's going to translate to all crops. Now it's going to translate a little bit differently, and again, getting into that timing aspect. Really, timing is a key component for building that response within the crops.
Yeah, the next question from the audience here is timing right after harvest. Is that best, or is spring okay?
Great question. So for us, what we're looking at on that is it's a spectrum. So the sooner you can put it on, the more feeding that you can have. So one of the things that I look at, so we talk about microorganisms, the bacteria and the fungi. You'll see terms where people say they're dead or they're inactive. The term I like is dormant, because I want to draw it kind of to that like how seeds work. That's kind of how microorganisms work in the soil, is they'll go dormant. Now, the longer they stay dormant, they could die off. But what we're trying to do is we're trying to get that activity, get their life cycle, get them to reproduce. They reproduce microorganisms. Those microorganisms are dormant. Can we stimulate them? So by going earlier, we're gonna supercharge that cycle. You're still gonna get aspects of it working if you go into the spring. Like, we basically at a quart rate, we're feeding that microbiome. That quart's going to last for about 14 days, and you're going to get an activity burst for subsequently beyond that for about 4 weeks. So in that process, where we're advantageous versus like a living biology is if you get cold weather, so you get freezing temperatures, our product is just going to sit there. Food will freeze. When it warms up, you get that warm spell in late fall or in winter. We're going to basically trigger those microbes to eat. And if they wake up, they're going to have something basically to kind of be active. So earlier is better, but you can still see that benefit. You're gonna have a delayed benefit or less benefit as you move closer into spring.
All right, next question. Can you explain why Phycoterra is a 1-year dated product and why?
So it is a 2-year dated product. The Phycoterra, the soil amendment and the residue management, that is basically just due to kind of general shelf life issues. So it's obviously a food source, so it's naturally occurring. It's naturally neutral. If we sent you product, we grow and raise it, process it in Arizona. That's where our company's headquartered. We send that to the Midwest. By the time it would get to you, like right after we grow it, the bacteria in the air would start feeding and contaminating it. So we have to, we basically put preservatives. We basically lower the pH. That keeps the microbes from using it. And then once we introduce that to the soil, we buffer that pH out naturally with the application, and then that can be fed. So the shelf life is basically due to that, over time, the risk of it feeding. That's the shelf life issue within that. We are 2 years with our Phycoterra product. That's what you would use for residue management. The seed treatment and the foliar product does have a slightly lower use rate, and that's just because the formulation and the preservatives are slightly different, and so we have to keep that efficacy there.
So our audience here, obviously a lot of strip tillers, they're doing no-till, they're doing cover crops, healthy soils. So, why is Phycoterra, why would you say it's a good fit for the strip till, no-till system, or people using conservation practices where they, their soil health might be better than others?
Yeah. So I mean, likewise. So in that reduced tillage environment, you have higher biomass, and that biomass is something you have to manage. So we're going to help manage that biomass. I think also when you have a healthy ecosystem, one of the big benefits when we get into the soil, the long-term benefit when we're feeding and we're keeping that active biome moving, what we're actually seeing is you're going to get more infiltration, water holding capacity. Your structure is going to improve because the structure is dictated by that microbial activity. They eat, they excrete their product. That's glue for our soil structure. And so those are critical elements when we're reducing that tillage environment. We need to have movement. We need activity within that soil to help kind of negate that aspect of having nutrients, say, for example, nutrient stratification. The benefit of that reduced tillage, the big benefit there is you're helping create that environment where those can strive. So you have the environment, we bring that food, and we see that compounding effect within that microbiology in those type of the strip till, the no-till environments.
All right, great information there. You guys must have covered it really well because we have no questions coming in right now. So I think we're going to go ahead and wrap up there, unless anyone else has one. We'll see if anything comes in at the buzzer here. But Chad and Dustin, thanks again for this presentation. Anything else you'd like to add before we go our separate ways here?
No, just thank you for having us host this, and very excited to, answer any questions or be here for any information.
All right.
Yeah, likewise. Thank you.